All good?
Yep.
Ja, hand alight, aqui na cena.
É a medida.
Aquela argumentação. Não precisa ser real time. Mas quando falar em inclinação, estavas aí?
Não.
Parecia que eu já estava.
Estou a tentar perceber. Já outra vez foi uma cena. Só queria partilhar isto, amigos.
O que é que está bem aqui? A resolução, esta cena.
Vamos internet, não está famosa.
Está a parecer uma slide.
Sim, não te esqueças que. Podes pôr.
Sim, posso passar para o outro, não é? Não.
Qual dos dois está a fundo? Estou a ver.
É o meu.
O meu também está a fazer barulho.
Ainda por cima agora tenho bem comunidades de Slack. Ai, o Slack. Parece que estou a jogar Cid. Isso é ridículo.
Tivemos mais 3 pessoas a inscrever-se. Às 5:15.
Vamos. Está bem, mas não. Deixa-me ir a só. Só.
Será que como é que costuma funcionar na apresentação desta?
Começam a no chat a risa.
Ah, é?
Basicamente simula que no chat a risa.
Mas pode simular as chapas acabam.
Mas tinhas que carregar não sei de qualquer para a
Não
ação.
é a secção, mas foi desse tipo.
Ah, não. Está para a secção. Tem só que colocar aqui o USB,
Vamos
não é?
baixar as luzes para ver alguma coisa.
O quê?
Precisamos baixar as luzes para ver alguma coisa.
Sim, temos que baixar aí o store. O meu computador ainda tem CDs. É que tipo,
Chega cá dentro?
Não, por acaso acho que. Não, por acaso até acho que tem um CD que foi a apresentação. Até acho que tem um CD que foi a prenda de Natal do Samuel, que é um CD com músicas da Claque do Porto.
Duro.
Pois é, amigos. É assim.
Let's make our part, right? Spread love.
Tá, né? Agora um bocado regime. Por quê?
It's our main goal.
Mas pronto, funciona.
Exactly. That's me. Hello.
Isto estava off,
Isto está
que ele estava a dar.
Mas eu ia jurar que esta net não estava assim.
Então, abortamos essa missão. A missão 2 é gravar com o telemóvel. O vídeo, se ficar bom, publicamos, se não ficar bom, não publicamos. É assim, plano A, plano B, temos tudo. Tudo pronto.
Podes pedir dentro.
Assim, entre estar bem ou não e o pessoal não ver e conseguimos gravar e depois o pessoal ver mais tarde, acho que é melhor assim.
Podes ter duas coisas, podes gravar e assistir ao mesmo tempo.
Sim, mas se o stream é uma treta, vai estar a, ou seja, o pessoal vai estar a desistir.
Deixa-me então um bocado mais gerido que isso, que é, eu não consigo. Isto é calma.
Olá. Hello. Olá. 2 horas depois. Hello.
Mesmo 12, bem.
Ok, então.
Não vai ser com o barulho depois.
Não é?
Pelo menos só depois com o barulho das pessoas que estão a vir.
Pá, o stream parece-me ok, apesar do meu computador estar aqui que não se aguenta. A minha questão neste momento é, o pessoal diz que não está a conseguir ver, portanto se calhar está perigoso. Exatamente.
Falem. Estamos a falar. Está a aparecer?
Aqui há uns 5 minutos. Near Hilton.
Ouve-se bem o teu sarcástico no meio. Vai ver o que quiser. Vai casa.
O link é o que está no... O link depois para partilhar com as pessoas. De fora é o que está no Slack, não é? De fora. Com outras pessoas.
Está público, sim.
Ok. Está a ser uma coisa. 22 tickets.
Vamos.
Foi?
O Zé a fazer conta daquilo que tu dizes no canal.
A fazer o quê?
22 tickets.
Vê lá, o Zé. 20 anos.
Dizem já.
Falta mais alguma coisa, João?
Inscrição para o evento.
O nome das pessoas para o check-in.
Inscrição para o evento. Posso ter. Faço copy para esse Facebook?
Sim. Não vamos complicar, não é? Isso é interessante. Interessante emprego.
erro na descrição.
Falta um R no teu cena?
Falta um H no vídeo.
Eu corrigi no Eventbrite, mas acho que não corrigi no Facebook.
Hã?
Corrigi no Eventbrite, acho que esse erro provavelmente corrigi no Facebook.
Eu corrigi em 2 sítios, no Facebook e somewhere else.
Obrigada, Ana.
Mas está no Meetup.
Que Meetup?
Temos como é que horas?
Pá, não sei, o último comprado de Lisboa costuma ser às 9h40 ou que é.
Já compras bilhete?
Não.
O último? Não,
Que já concerto com a Arena, juntos por todos, por causa do incêndio. Por isso eu diria que vai ser complicado.
Hã?
Porquê? Só vai durar para uma hora.
Ah?
Só vai durar
Se as
para
pessoas
uma hora.
forem virem ao concerto, depois vão correr por casa. E a questão é ter lugar no comboio.
Aí a tua questão é essa. Então podemos já comprar. Não fazes como outra vez, dois bilhetes para Coimbra, um bilhete para o Porto.
Mas isso funcionou bem, para os requisitos.
Funcionou. Não, foi aquilo que tu compraste para Coimbra e depois compramos outro de Coimbra para o Porto.
Ah, isso já aconteceu, é verdade.
Até gasta no joelho. Não devia ser amanhã.
O meu conta estava aberto. Eu comecei a fazer cena com M's e tento fazer.
Epá, não consigo ler toda esta mega conversa de café. Por escuridão.
Marca como livro.
vai acontecer hoje?
Na própria isso.
Tudo bom? Olá. João. Olá. Tudo bem? Olá, João.
Se calhar ainda vamos fazer aquela esperinha de 5 por 10 minutos para ver se chega mais gente.
Depois quiseres, depois.
Ok, está bem, obrigada.
Fizeram o da aplicação?
Sim, sim,
Está a
está a funcionar, sim.
Sim.
Querem, se quiseres fechar, pode
Era só
fechar.
ver a resolução.
É que a gente já aconteceu. Ainda agora tivemos a dizer que foi a mesma.
Saímos agora de uma capa cortada, caralho.
O gajo foi cabo a app e dava assim metade cortada.
Eu um bocado estive a testar.
Para a frente.
Next.
Ok, está bom.
Está fixe, está fixe. Já,
Não
está.
Deixa eu ver se está assim fixe.
Está despido.
Então agora decidiram vir de vez em quando aqui abaixo?
Sim, precisamos experimentar. Já temos analisado algumas coisas lá em Coimbra, já não sei do que vai ter também. Sim, mais assim.
E aí, mais facilmente pessoas vêm, eu não sei, é lixado, a gente também já fez cenas de eventos e coisas assim, pá, e quando é, imagina de eventos que tem colos e o pessoal diz, eu vou, e já lixado.
E não só, ou seja, a questão também é que nós em Coimbra, o que nós sabemos é que nós já conhecemos quase todas as pessoas nos eventos. E só quando nós conseguimos puxar gente que vem de fora para apresentar alguma coisa boa,
uma cena diferente.
É que mesmo para nós é que nós aprendemos alguma coisa também desafiante, um bocado já. Com essas técnicas às vezes é interessante, ficar para puxar o pessoal e com certeza é massa crítica. Mas eventos mais pequenos para falar de coisas específicas, tem muito mais. Não só a Lisbon para lá, ou vice-versa. E na verdade, como nós já temos um bocado a cena distribuída, mas nós, ironicamente, acho que estamos mais distribuídos. Ou seja, a maior parte das coisas lá fora, se calhar um bocado de exceção, e por isso nós temos andado um bocado desligados de tudo o que é Portugal. Estamos agora tipo, a mapear um bocado
back to basics. Por acaso agora, tivemos agora à tarde, por acaso, hoje é um dia mais de cenas do workshop, assim, porque a EDP tem uma, pronto, vocês no estado ali, há uma cena que é o Free Electrons.
Sim.
E o encontro agora foi este fim de semana e agora mais 2 dias, é aqui em Lisboa. Temos a apresentar precisamente isto, também dar um bocado a visão do smartphone.
Nice. Sim, super legal. Ainda estivemos a pensar que ainda estamos com uma parte dos anos a fazer, mas é interessante, porque tudo pela escala.
Ganham visibilidade do pessoal do mercado, tem alguma visibilidade. E depois eles têm estes encontros, portanto, sim, dos dias, nós também estivemos há uns tempos, aliás, o último em São Francisco. Os gajos estiveram lá ainda uma semana, e tudo é fixe. Nós estamos lá também uma semana.
Nice.
Realmente estão muito o gajo sente-se muito pequeno. Vocês provavelmente, imagina, vocês já estão, o ritmo já é diferente, imagina que é um gajo que trabalha no meio daquilo, mesmo por muita dinâmica que seja a nossa área, chegar lá, aqueles gajos,
Sim.
É um mundo à parte,
Por acaso, São Francisco nunca foi, mas nota-se logo a diferença, ou seja, não só cultural, como estou a trabalhar com pessoas dos Estados Unidos, e mesmo dentro dos Estados Unidos, as zonas onde eles são. Se esquecem para estará, o pessoal não havia aqui um bocadinho mais triste e tal, mais calmo. Mas também se nota muito, por exemplo, quando nós vamos para algumas zonas de longe, zonas mais startup, também tem uma diferença brutal ao cotidiano.
Eu não estou na área profissional, mas eu ainda vivi durante os tempos de Londres, há uns tempos atrás. E nota-se isto, é um ritmo, as coisas acontecem. Mas depois, a zona do Val.
Sim.
Os gajos têm um conceito. Uma das coisas assim mais engraçadas que eu aprendi lá. É uma cena. Sabe aquelas coisas que te abrem que quando aqui fazer? Os gajos têm um conceito que é um prof, que agora o gajo dá umas palestras e tal. O gajo foi um dos primeiros engenheiros, é um gajo italiano, foi um dos primeiros engenheiros da Google. Foi um dos primeiros diretores de engenharia da Google, quando começaram ainda era um motor de busca, simplesmente. E o gajo, portanto, fartou-se daquilo que dizia que a Google estava a inovar pouco, vemos o nível do social. Fala-se, pronto, são umas startups, vendem por quantos, umas fez um IPO, o resto é guita e pronto, agora decido dar assim umas palestras. Então, o gajo tinha um conceito, que ele chama pre-prototyping. Ou seja, ele diz que a cena do protótipo é uma cena que toda a gente faz protótipo para testar, para ver o conceito, etc. O gajo dizia que aquilo no Val há o pre-protótipo, que é antes disso. Então, a cena do gajo é falhar o mais rápido possível e aprender o mais rápido possível. Não vale a pena perguntar que é fixe, não vale a pena perder muito tempo a fazer um programa, não sei. Então, todos os exemplos que o gajo deu, eu disse que os anos para aí, princípios nos anos 80, o gajo não estava na rua. os gajos tiveram a ideia da cena de, quando escrevia, a cena do voice recognition, escrever. E então, na altura, pá, toda a gente ouviu isto, pá, os gajos pensando, então, em vez de andar o gajo ali, em vez de fazer um programa, os gajos, como é que ele testou? Em vez de fazer um software, contratou uma gaja que escrevia bué rápido, teve uma sala de escrever. E depois toda a gente dizia aquela cena, que era espetacular. Passado muito tempo, começaram a surgir problemas, o pessoal ficava muito cansado a falar, cansado e perdia a privacidade. Ou seja, o gajo diz que na altura, aquilo que toda a gente dizia quando se perguntasse a alguém o melhor produto do mundo, uma série, aquilo toda a gente dizia que era o meu produto, afinal ninguém queria comprar e o gajo testou aquilo em 2 dias. E então esse é o conceito do pré-protótipo, de testar tudo, e para eles, a cena do lado do Roger é ser um por semana. Eles dizem que não há menos do que um por semana é pouco.
Sim.
E então é o ritmo. Quando pensar aqui que é fazer uma menina.
Por acaso isso tem mais que há muita cultura de fazer as cenas com o MVPC manual, basicamente, é um bocado esse padrão. Não programar nada, fazer a nossa função de ou então o F-Fox em falar com pessoas antes de construir coisas com ideias.
Sim. Eu gosto muito de do the right hit before you do it right. Ou seja, antes de fazer a merdinha toda bem, portanto, tens que descobrir aquilo que as pessoas vão querer comprar. Antes de descobrir isso, vale a pena dar como destrabalho. Era um bocado para isso.
Para não desse género, isso por acaso tem sido um bocado o nosso tema mais recentemente, melhorar a nossa cena, fazer coisas com inovação. Muitas vezes nós temos ideias para, seja do ponto de vista do negócio, como é que vamos distribuir isto, do ponto de vista de tecnologia, como é que vai ser distribuído. Nós perdemos tanto tempo a pensar como é que nós vamos escalar esses modelos de distribuição, que nós não fazemos as coisas básicas, que é tipo falar com os primeiros 10 ou os primeiros 100, e assim, basically works.
É um bocado
está tudo um bocadinho ligado.
É um bocado do espírito do gajo. E o gajo dizia que temos que estar na vida real. Não vale a pena andares com. Perguntar a um gajo se é fixe, porque o pessoal lá a partir diz que é fixe, mas depois. Sim. O gajo diz: não está simpática, não é? Se apareceu uma barra, sim. É um bocado o conceito, as pessoas simpáticas, as pessoas arrogantes. O que é que dizem para ver? É fixe, não te deixa. Alguém diz outra que dizia: o Big Brother, quando fizeram um pouco disso, foi a pior classificação de sempre no programa.
Ninguém tem coragem de dizer que
ninguém diz. O que é que vai dizer que gosta de ver 50 macacos fechados numa cara? Bem, por acaso foi uma viagem mesmo enriquecedora. Quando estivemos a apontar o Google X, ou X, ainda mais. Vai ser
Sim, mas digo que nós também devemos dizer que normalmente quando nós estamos a anunciar algum tipo de propostas como modo nos Estados Unidos, entre nós temos uma oportunidade de fechar, às vezes é tipo 2 ou 3 dias, e sobretudo nota-se que existe uma população brutal entre nós temos respostas, nós respondemos a elas, converte muito mais provavelmente, 24 horas para eles é uma oportunidade. E é uma cultura bem diferente.
É totalmente bem, não percebi aqui a mesma cultura do 50 slides de PowerPoint, 50 páginas, depois moras no mês, mesmo os vídeos, com 2 books, that's it.
Uma empresa que é Betalos, não sei se conheces, também as empresas nós estamos esperando mais por viagens, é muito orientada dentro dos estudos, ou seja, se chegam aos estudos, e os critérios que eles têm, sobretudo para a parte de investimento deles, que é quase assim, é não haver PowerPoint. Tem que mostrar um protótipo, tem que mostrar o que é bom e mostrar que já provaram isso. uma da parte que ela é muito cultural, é muito fácil abordar com nós. Começa muito abstrato.
Como é que está? Basta pôr o input.
Se tu para depois tens que começar a experiência por usares por uma coisa, ok, isso sabes o que
é bem.
ou então, isto é utilizador, já também que o pessoal está a ser esperto. Isso elimina muito. Então não precisa de mais isso.
Eles querem ser utilizados, também querem ver que cenas aconteçam. Venha que manda mesmo na cena.
Alright everyone, so we are about to start. Do you have English speakers in the house? So just to know, okay, so we're doing English?
Yeah.
Alright, so thank you for coming. So this is Digital Meets Physical, so this is a series of events that we are doing throughout Portugal for now at least. We are Whitesmith, so here's a cute video about us. We develop products either for our own, also for some of our clients. Our specialty is basically build full products. So we are full stack from hardware to design and product management to the entire layers of the product. Especially we like to work on the early stages or help existing products to have new features. And so as our thing is a little bit about intersecting the digital experiences with the physical stuff, so hardware, Internet of Things, AR, VR, and so on. So we are starting this series of meetups to basically bring together people that are already working on these areas and sharing some ideas and get to know stuff. So without further ado, so we have João from EDP. Like to start?
Yeah, of course. Podes começar? Okay. Very good. So, hi everyone. I'm João Man. I'm from EDP. You might think, why EDP is here? I like a big company in a very traditional market. But even in big companies, we have to innovate. So we have like startups inside like little startups working inside a big company. We are from a concept team that we create a concept named EDP Smart Home. And why is this? Why we have like 4 million clients in the retail market? We have like networks, we have everything. So why are we doing this? Because if we don't, someone else will do. Imagine the computer market, the PC market, where in the 60s we have like mainframes, right? So nowadays, a few decades ago, we have like a PC in each home. Nowadays, in our pockets, we have a PC, right? So in the energetic market, I think it will happen the same. A few decades ago, there were like a big central producing energy. A few years ago, we had like eolic wind farms, but all centralized. In the future, we are seeing that it will be all decentralized. Everyone will have solar power, will produce energy in their home. They will store their energy. They will manage their energy. They will have an electric car. So, if you think that each one of us can like produce energy, store energy, manage energy, so you are an utility, right? That's exactly what EDP do: produce, distribute, store, and manage. So if you think that, is it possible that like the grid will be only like a backup of the client if there is no sun, or if I plug all the devices in my home and I need some part of the grid? Yeah, it could be possible. So in EDP, we think we are creating like, we have a vision. We have a vision that the market will go in this way. So we have to, it's not only, a few years ago, like our we didn't have customers. We have like the users, like switch on, switch off, and that's it. We believe that in the future, more than switch on, switch off, we have to have a relation with the client. And as I said, a client home will be like all the entire, a small network that has to be connected, like our PCs, like our phones that are connected and have to work connected, right? So this is EDP Smart Home. And why technology, why I'm talking here, and this is about technology, right? But all these effects, all this paradigm shifting that I told you about, is driven by technology, by solar panels that is getting cheaper and cheaper, by IoT, by electric cars, by everything. It's technology. And if a big company and in an energetic market and in all other markets don't fit to this new kind of paradigm, and that startups will get new ideas and have a much faster time to market, we have to work with you guys. We have to be aware of this kind of paradigm shifting, okay? So we created EDP Smart Home that's, it's like nowadays has 4 main products: solar energy, electric mobility, and EDP ready and batteries, okay? So like as I said, like this is an utility inside everyone's home, right? So as technology is like the cause of everything that's it's here, I think technology is the answer to all this also. So let me show you how it is a smart home, an EDP smart home. It's an electric car, and we are going home, right? And inside there's a guy, but in the future it might be like autonomous driving, and we have geofencing, and someone knows always where we are. Our home knows where we are, and the air conditioning was turned on because the house knows that I'm going home. I'm leaving my work. I want to when I arrive at home, I want my home to be comfortable, right? So I arrive home and I will charge my EV. I want to know how much my EV is charging, how much does it cost, and I want to schedule the periods of time that I want him to charge my car, because as you know, in Portugal we have like tariffs. Most of the tariffs are cheaper at night and more expensive during the day. So I will schedule my car to work from midnight to 8. So I will put my car into charge. And one interesting thing is that one of the problems that the EVs have inside my home when I have an EV is like when I charge, the power in my house will rise a lot, and most of the times rise above the contracted power. I don't know if you are familiar with the concept, but you know when you plug in many devices, your switchboard will turn off, right? So what you are working in this is that when I plug in my car and when I for the microwaves or the oven, when I switch on, the load going to my car will go down, and when the microwaves will shut down, it will rise again, all automatically. Because one of the that's the marketing side of the thing, is that our clients, the clients don't want to like, okay, turn off, turn on, schedule. They don't want that. They want you to learn, EDP to learn, and to schedule and to optimize for them to be automatically, right? So the second product is solar panels. Solar panels are our most known product of the smart home. We have like 10,000 systems installed already in Portugal, and with every solar system we offer like EDP Ready, that is our smart home system that will allow you to know what are you producing, what it goes inside your home, what it's sold to the grid, and it's very important because people want to. More and more people are critical. People want to know what they are buying, what they are producing. They want to know information about the things, right? So let's go inside home. It's a nice home. It's not mine, unfortunately. But it looks good to presentations, right?
Half a million.
Maybe a little bit more. Yeah, okay, in Portugal it can be. So, as you remember, the geofencing turned on the air conditioning, but I can control my equipment manually. So with EDP Ready, I can also like change the temperature, control the temperature of the air conditioning. I can control other equipments. I can, for example, here in the TV, I can schedule only to work during the night when I'm home, and works like a standby killer. And I can schedule everything, right? Here I turn on, that's what I was talking about the EV. I turn on my coffee machine, lots of power, and automatically ready, switch off the washing machine, just to take my coffee, and then when the coffee machine will stop work, it will turn on again. And that's like the kind of relation that we want to have with an utility, because here, I don't know if you know these kind of numbers, but each of us spend like 8 minutes a year with their utility. That's the average. 8 minutes is very, very bad. And if you think that 8 minutes are almost all the time looking at the bill, so it's even worse. So that's a shame if we think like a marketing guy that wants to work with their customers and they spend 8 minutes looking at the bill. So this is the kind of things that we want to work around, because we want our clients to see the utility as a part of the solution, not part of the bill, only the bill. That's the kind of things we want to work with. Other things that are very significant is like notifications, because actually we don't know anything about what's going on our home. Where am I consuming? If the fridge is working properly? If everything is working? What is working properly? What is not working properly? So here we have a notification about the pool pump that increased a lot of the consumption. This is not the real, but it happens. It has already happened with some clients that the pool pump was broke and spends lots of money. And so the next step is to propose to our clients an efficient schedule. We don't want only to okay, it's working, something was wrong. We want to say, do you want to schedule your pool pump to work only at night, that the electricity is cheaper, right? So let's accept. And other things that we can, with Ready, we can like see all the consumptions and the production of the house to monitor that, forecast electricity bill in the end of the month, and also lots of things that we are working is putting like intelligence inside of it. And we are working with Whitesmith in this. We don't have yet in the app. We have a monthly report that says to the clients stuff like this. Maybe you have a single tariff that is the one that is all the same price all during the day, but we can like with data, and data is a very important word in all this, right? We can say to them to clients, okay, if you shift to a dual tariff, you will save. Okay, you have the right contracted power. It cannot be lower. It cannot be higher. Oh, okay, some kind of achievement. You were like the best solar producer in the district of Coimbra. So please share it. We want that's the marketing side of the thing. We want people to share. We want people to, and we are also working with Whitesmith on this. We want people to share. We want people to put EDP Ready and solar energy EDP in the social media. Other people that click in this will receive something because click from a friend, and all this referral thing. We are working a little bit on this too. So, how does EDP Ready work? We have, like the app is the interface, we have also a portal, but most of clients use the app. We have like the EDP Ready box that is like the center and the brain of everything, that connects everything. And we have like these peripherals that we developed, because why? Okay, these things like the smart homes and IoT, it's all very cute, but which one of us has a smart fridge or a smart AC or a smart washing machine? None, right? So in the future, we know that we will have it, because maybe all the ACs, all the washing machines, and all the ovens and all the microwaves will have connection and will talk together and will be smart, right? But for now, we don't have it. So we like build some kind of devices that are like function like bridges between the Ready box and our regular devices at home. If you plug, like imagine, if we have a plug, if you put our fridge connected to the plug, to this smart plug, the fridge will connect it. I can schedule, I can monitor their energy consumption, I can turn on, turn off, I can, and with all the data that we get from the client, we can advise them to work efficiently. So just to recap, we have this kind of 4 products, all driven by technology, and as we saw in our smart home, all the answers are technology. Our technology, our intelligence, our big data, and we are working a lot, even inside a big and not so fast company. But what we think is that we have to work a lot with startups. We have to bring your energy, to bring your quickness to do things, and to the way of thinking, the way of working. And that's why we are creating like a community on the cloud for startups to develop and to help us developing these kind of steps, this kind of intelligence that can help us bring our customer relation to another level. So, and thank you. Please feel free to ask questions. Yeah.
What kind of plugs are you planning on using for turning the dumb equipment into smart equipment? Is it attached to the equipment, or is it attached to the plug?
It's both. Actually, I'm the marketing guy. I'm not the client, but I can answer that. It's like a plug that you plug into the regular plug. It's an equipment. I can go back. And if you plug like your fridge, you plug this smart plug into your regular in the wall, yeah, right? You put the fridge into the
Plug?
Sorry?
Into the smart plug?
Yeah, it's a smart plug. You
It's
plug it
between the plug and
the fridge,
plug on
the device,
and the plug
yeah,
of
the socket. And I don't know. Sorry, I don't know exactly in English.
Let's be specific. For instance, if you have the microwave.
Yeah, you plug the microwave into the smart plug and the plug into the
within
grid.
a
Yeah.
specific plug, but that plug might be used for other equipment
Yeah.
too, when you are not using the
Yeah,
devices.
yeah. You can switch. You can buy more and more,
So
or you have we have like smart plugs. We have like a smart meter that it makes like the same kind of things of the plug, but for electrical, like an AC. An AC don't have a plug. It's in electric circuit, right?
Like this?
So, yeah, that's it.
The plug on the wall, the
Yeah.
plug, and the
And
plug
for those equipments that don't have this and that is included directly into the electric circuit, we have a meter that we can do the same thing. We have a solar plug that do the same thing, but instead of monitor what consumption is going this way, it measures the energy goes that way for our home. What we are producing and injecting into our home. We have like a smart plug AC that has like infrared that allows you. It's like the command, the command of the AC, and stuff like this. Nowadays we are building ourselves these kind of bridges, but we are also working in the integration of already smart devices like motion detectors, opening and closing doors, smoke detectors, and so on. I mean, as the market evolves to even more and more smart devices, this is a Zigbee protocol, so we can put all the products that have this kind of protocol, we can integrate in this. Okay, you can say, Apple is working on this with it launches HomeKit. Google is working with Nest, that is a thermostat. It's not like a thermostat. It's like a connected home that it works like a thermostat, but is much more than that. It integrates all the equipment that connects with Nest. So why the hell are ADP working on this, right? Are we going to compete with Google and Apple? No, we will not. We don't want to. What we think is that we can be like the specialists in the energy side of the smart home, because for sure we know much more about energy, about contracted powers and everything. And if I produce, will I store? Will I consume? If I want to consume, should it be from the grid? Should it be from the storage? Should it be from the solar? These kind of questions in the future will have to be answered. And we think we are the guys that could answer the better way inside the client's home, because we have the information, we have the knowledge, and we want to be the first. We want to have the first mover advantage. Okay. Yeah.
Presently, quite 90% of the mail activity is used by scam and phishing and all sorts of bad things.
Yeah.
Okay, so it is consuming a very high level of energy for internet, because only 10% is real email between people that want to exchange things. So my question, when we have many things that are measuring, what is the level of consumption which is added by the measure and the transfer of the information? Because what the people want is to be automatically with the lowest
effort
invoice that could be possible.
Yeah.
Perhaps it could be interesting to have more data, but the main thing is to pay nothing or quite nothing. And to develop automatic things, it's perhaps better to measure that we use only a few.
I don't know if I exactly understand what you are asking, but what we don't think people want to see all those beautiful graphics.
Yes.
People don't care. We see all the time. We see all the time. People don't care. People don't. Okay, it's funny. In the first time, I will leave the work and okay, I plug my AC to turn on. Okay, it's okay. So it's fresh it's cool in my home. But it's one day. I don't want always to turn on, turn off, schedule. I don't want that. What I want is for the utility or for other company to learn what I want and to work for me. So what we are trying to reach, of course, the first step is to give information. The second step is to advise, right? These kind of three steps are always in our minds. First, monitor. Second, advise. The third one and the last one is to act for the client. People don't want to care. People don't want to care. People want at the end of the month to have a smaller bill. So that's why we want that kind of things, that the pool pump is working too much, and I click in one button to say yes, schedule to work at night. So, but this is, okay, it sounds easy, but it's not easy because the example of the pool pump, we need to have the information about the size of the pool. If the people have the pool working during winter or not. There are lots of questions, lots of information that we have to know about the client, and you know better than I do all the data that is produced from this thing. We have data from each I think it's 15 seconds. So from all the plugs, from all the meters, from everything, from inside our client's home. So the next step is to bring all this data together, bring intelligence into it, and work for the client. Not just give information and make the client work. They will not work. And they will not care about the product, and they will not pay for the product. They just want them to... What they are expecting is, I arrive home, and I have my home working properly for me, and with the lowest energy bill, right? And just to add, in the future, a lower energy bill is not consuming less. If I ask you what is energy efficiency, I think most of you, I don't know if it's true, but I will guess, most of you will tell me that is reducing our consumption, right? It's not. In the future, it's not. I always like to make a comparison with the telecom market. A few years ago, when our price was per minute, right? We pay for each minute we talk. Nowadays, every one of us pay for minutes. Maybe not. We'll pay a fixed price, right? Because why? Because the costs of the telecom guys are the network. If I talk 1 minute, if I talk 100 minutes, it's the same. They will not have a marginal cost. For the electricity, it's the same. It will be exactly the same. Nowadays, some parts of the day with renewables, at night, the cost of energy is literally zero. Because they are producing. We have the investment, all the cost of maintenance are the same if I produce much or less. So the real cost of producing marginally energy are zero. So what will be energy efficiency? Energy efficiency will be if I consume in the right time, when the cost of energy is zero, because that will reduce my bill. Not if I consume less. If I consume less, but in the times that the price of energy is very high, that's not saving. The saving is if I switch my consumption from the parts of the day that the energy is very high, is very expensive, to those where the energy will be less cost. Okay.
If the transportation of energy was not losing energy by itself, we could connect places on the world. When the people are sleeping on one part of the world, the energy could be sent to the other people where they are using it in the day. But the energy...
There are lots of
depletion.
Yeah. Because of the transportation. Yeah, I could spend a little bit working, talking about the futures of energy and projects like Google X that have like in the atmosphere or stratosphere or something like that, turbines and connecting with Wi-Fi, transmitting with Wi-Fi energy. Okay, that's, I don't know, I'm not the technician guy, but okay, there are many possibilities. What I'm sure about is that it will be decentralized. These kind of things that we have like one very big central producing energy. Yeah, it will. I'm not saying that it will not be those kind of centrals, but it will be much less, because there are always some, like a week ago when it was like 45 degrees. Okay, everyone was switching on the air conditioning. Okay, we need the central, but most of the time we don't need them. We just need renewables. And as I said, as we've done the investment in the renewables, it's fixed. So I just only have to pay. It's like the telecoms. They input the network. It's fixed. If a guy consumes more or less, it's the same. Okay. So, and that's another very interesting thing about this. I didn't talk about, but when I show you this, we just look inside client's home, right? But if ready, we have some plans for ready too. And it will be very important in terms of the management of the grid. I only talk about the retail side, not the distribution side, but it's very interesting because it will be much less expensive to imagine that in that day of the 45 degrees, if I pay each of Portugal's clients to increase their air conditioning by 1 degree. Nobody will see the difference. The difference between 20 degrees or 21 is the same. Nobody will see it. And the consumption will decrease. I don't have to, if I can decrease the consumption, I don't need the central. So I can, with the costs of the investment and the maintenance of the central, I could pay the clients. So in the future, I could say, I am the grid manager, and I could say, okay, I pay $10 to switch to increase one or decrease 1 degree of air conditioning. I can pay you like $20 if you have an electric car, and I could go to your battery and take like 20% of your energy. So these kind of things will not be in the consumption side. It will be very important in the terms of the distribution side, in terms of management. This is kind of buzzwords like demand side management and vehicle to grid. Maybe you have heard about it. But okay, it's not a question today, but you know better than I do. These kind of things. In a few years, it will appear. Like I was talking about with Rafael. We have the opportunity to be in Silicon Valley, and the things are like we are in the streets, and there is an autonomous car walking around, you know, driving. And okay, I thought this will be in 2030. No, it's not. It's actually not. So things are going quick, and we have to adapt. We have to be fast. We have to test. We have to test the market. We have to design the experience of the clients, to know if they want to monitor, if they want to be totally automatically. We need to talk to them and to know what they want. Right?
how do you deal with this kind of new projects? Do you have a separate team?
With many difficulties. No. Yeah, no. Actually, there's some kind of discussions inside our company. There was always a discussion if it's better to build another company, to be autonomous, to have like another spirit and another working pace, you know. Today we are working inside, but we have like a semi-autonomous team, and we work a lot. Look, with Whitesmith, there are not so many teams inside EDP working with startups and making like video conference to make the meetings. And we have met like personally like 2 times, and we are working like more than 1 year. And okay, it's not an autonomous company. We are like a semi-autonomous team that okay, we are working with all the big companies and all the companies like communication, billing, everything. Okay, we work with the big company, but we have some kind of independence in terms of thinking and doing small things, small tests.
But all the people are working on their daily functions, and besides that have this kind of
no.
project, or they are
no. Our team is just focused in this. We are just the marketing. We have like working on smart home. We have like the operational team that install and manage all the installers that go to clients' homes and install the solar panel, and that team is the team that is shared with all the company. But only working on this, we have like the marketing guys that me and Nuno, we are part of the team, and we have like the innovation guys that are the techies that think a little bit and like more kind of fear that's working in technology and works a lot with Rafael too. And with Whitesmith.
You also failed to mention that you have EDP has quite an open scheme for working with startups. So you are supporting a lot of startups, and it's also a way of bringing the innovation in-house, from what I understood.
Yeah. Different things. Well, we have like a company that is EDP Innovation. That is another company. It's not inside the group, but works in a very high level and always seeing the future in the long future. And actually, they have like programs like the EDP Starter, and also some kind of venture. They invest in some companies. That's EDP Innovation. Within EDP Commercial, what we are doing in this innovation team that we have in Smart Home, we are few people. We are almost like a startup. We are very few to build all these things, and we had not the time to market that we want and that we think we need to face this kind of market. If we want to compete with, not compete with Google and with those kind of companies, we have to be fast. And we inside, as we are few people, and as we are not so fast inside our company, we are like building a platform in the cloud that, for example, we'll put in the cloud all the data that we collect with this. All the consumptions, all the productions, all the equipments that people have at home, all the habits, at what time they are going home, at what time they are going to work, you name it. It's massive. The last time that they use the app, the last time they schedule an equipment, everything. So what we are doing is like creating a platform that every startup that we are launching like small. Look, I'll give you an example. I think it's better. We want to make like an automatic program for the air conditioning to work efficiently. Okay, so we launch a contest within startups and universities for the project, and we'll give some access to the data. Okay, so they can build like software or algorithms to do that. So it's like an open innovation resource that we have the data, and we open to many startups for them to work with our data, and for us to integrate your working in EDP Ready. Okay. So because we don't have the capacity to do internally all this.
Software. Sorry to interrupt. You're buying also this software that these people are.
Yeah. It's like an open innovation because we don't have capacity. We want more and more to have internal capacities of software and techie guys, but it's slow. But hiring people, and we cannot like freelancers and everyone. No, we can't. So the way that we find to put this is like this open innovation source. We are developing. It's not working already totally, but we are creating this in the cloud. Whitesmith is also beginning to work with us in this, so it's really nice.
Sorry. You mentioned how all the equipment are connected in the smart home. What I would like to understand is the wireless communication protocol. How is everything connected? How do the equipment interact with the main kits and with the smartphone app?
Okay, I will try to answer. I'm not a techie guy, but I'll try to answer. So, the protocols are like the ZigBee. These smart plugs, connect with via ZigBee with our EDP Ready box. Okay? And the EDP Ready box is connected with the internet of the client. So we have access, we connect with the gateway at the box, and the box has some intelligence. There are some kind of things that are done locally in the gateway, in the box, and there are some kind of things that are done in the cloud. Okay? So we have this, and we have the PLC for the things that like the solar panels that sometimes are very far, or the charging station for the EV that it's like in the -2 of a garage. We use the PLC because it allows longer distance. So these are the two protocols that we are working. I don't know if I answered properly what.
Yeah, thank you.
All the plugs have the two ways, the ZigBee and the PLC?
No,
You need specific.
Yeah. So, sometimes even in solar, the plugs are always with ZigBee. If they are very far away from the gateway, we use a meter with PLC. If we are close enough, we use this. It's like a plug-in. We want to make all our like a solar panel. Actually, we have the solar. We put there. We plug in the socket, and that's it.
So I want solar panels on my roof.
Yeah.
I contacted DP, and they told me, okay, we can put 2 panels of 2 square meters on the roof for your home.
Yeah.
Okay. During a meeting of the co-owners of the building, I tell them, okay, I want solar panels. Okay. But it happens that all the co-owners, they also want to have solar panels on the full. But the place is limited on the roof because there are still solar panels for hot water. Vulcano. So I cannot say to EDP, okay, come to install what you wish to install, because I don't have the permission, and it should not be wise and kind from my side, because the other co-owners will not be able to put some solar panels. So will you propose something that will not be adapted only to individuals and to morajas, but also to building, in order to share the possibilities of the roof between all the co-owners?
Yeah, as most of us probably work within apartments, right? And the relations between co-owners are always difficult for them to approve the things. So there is, by legislation, you have to have the approval from other co-owners for you to put the panels.
That's right.
If they don't want you to put, you cannot put. So that's a problem. Even if they want all to put, there is like some kind of limitations in the connection, because you have to actually plug in the electricity into your home. If you live in the first floor, there are some kind of problems. Of course, you can put the panels, and the panels will be used for the common parts of the building, for the elevator. But it's not. We have with Redi, we have monitor the consumption of the building, and they are not so good for solar because they are very peaks with like the elevator. Like it's like this and like this and like this and like this. And for solar, it's not good because the solar is like the continuous curve, and you will inject a lot into the grid. Saying this, we are, as an innovation part of the thing, we are working in a new product. Maybe we'll launch hopefully in the beginning of the next year. That is a product that will allow people living in apartments that don't have space, or even people living in single homes that they are not at home during the day, and they will inject all the grid, the electricity produced into the grid. We are working in a new product where people could buy. This is a secret, right? You cannot tell because we are working on this. People will buy the panels. They will install it in. We will install it in some kind. Imagine like a factory, and building that has conditions to put it, and it's your own panel producing energy for other place, and the revenue from this panel will some part be yours, and some part will be of the building that has like a renting fee.
Okay.
So we are working on this because we think it will be like increase a lot our.
How about solar panels with batteries? For example, for the common parts, we have peaks of the elevator. For example, in the morning where everyone goes to work. Even in the afternoon, and when everyone comes from work.
The batteries have one little big problem nowadays. They are very, very expensive. Nowadays batteries are for the ones that say, I don't care about money, I just want to be green and to reduce my energy bill for like 50 to 60%. Nowadays are like this. So even technically it's not the best solution, because even the battery has an output power. Instantaneous power. Even in the peaks, they cannot respond instantaneously.
And for example, if you have a high demand for energy, can we put the panels and we have sell it to you, and then
no, it's in Portugal. It's not possible because we have. In a few things we are advanced from other countries, and solar energy legislation we are very far from most of the countries, because we are I think the only country that has only no like subsidies. The people only will win what they are self-consuming. If they inject it into the grid, it's losing. So you cannot sell. You cannot sell.
The idea here is
you cannot sell to the grid.
Yeah, the idea here is we wouldn't sell to the grid. It's like making a backup. For example, I produce 60. I inject in the grid 40.
Yeah.
When I need, I could get the 40 back.
Yeah, but in practical terms, in terms of revenue selling, because you are using you are using the grid as the storage, as a battery, but it has costs in terms of the grid, and there are lots.
For example, if you have high demand on energy, my 40, you would sell it to someone else, and then
of course. In the future, that will be possible, and actually, it will be expectable. But that's what I was saying about this kind of demand response and vehicle to grid, the relation between the grid and client's homes. Yeah, in the future it will be, but you will have to have a very smart grid, and you don't have it. You have to have a grid that connects and communicates with each home to know, okay, I want to buy it, I want to sell it, I want to go to the battery of the car and get your energy, and I will pay it. I want to go to your solar and get your energy. I want to decrease your AC. So that's in the future. It will be possible. It will be expectable. But nowadays, here in Portugal, actually in Europe, it's not. It will take a little bit. In the US, yeah, it's more developed in the in California market, because they have actually lots of problems with the grid, because they have lacks of production. There are shutdowns, and so they invest a lot in the grid to make this kind of connection. Actually, they are offering batteries to clients for them to store energy, and for them to go there and to pick up the energy when they need it.
Okay. About the technology of the solar panels, there are some systems that are tracking the sun. So
yeah.
It's look at the sun, and it's ready to give information to the motor to move the panels to stay always facing the sun.
Yeah.
This is more expensive because you have the system to track, to give the information, and to conduct the motor. So, is it interesting if you compare the cost of this system?
The quick answer is no. And why? Because in the beginning, in 2011, 2012, it could be, but as the market of the solar market increased a lot, the solar panels decreased a lot of the price. Only the solar panels. The I don't know to say in English.
The managing.
This kind of thing. The tracking system doesn't reduce its cost. So it's cheaper for you to produce the same amount of energy to put more panels to produce the same amount instead of having the tracking system. And besides that, the tracking system is a mechanical thing, and mechanical things most of the times have some problems. One of the beauties of solar panels is they are stick and into the roof, and that's it. You don't need to do anything. They will produce energy, and they will not have problems. Sometimes you just have to wash them. That's
perhaps
it.
The new surface of the solar panels has little lentils in order to receive and optimize the sun ray coming, and whatever should be the angle of reception.
Yeah, everything is possible. But the problem is that we reach some kind of the solar panels, the polycrystalline that are the regular ones, reach a huge mass production, mainly in China. So they reduce so much the cost. So it's, when you compare with other technologies, it's always much more cheaper to put lots of panels to produce the same amount of energy. The problem is that, you have space limitations sometimes. So there are always some kind of new technologies to produce for the same space, for the same square meter, more energy, but they are quite expensive.
The new system you are telling about that will probably happen next year, it's quite an investment to invest money to have solar panels somewhere, and then you receive a credit to diminish your bill. But if you compare, you can also buy shares of EDP, and you will receive an income with dividend. What is the best investment? Because there is an investment from this and investment from this. It's quite the same.
It's an investment. You can see that in an investment point of view. It's totally agree. It depends on the investor. If you want to invest in stocks or for EDP, that's one. You have one rentability and one risk. It's like all the investment. In solar, you will have that too. You will have some risk, and we'll have some return. So it's kind of a decision. It depends on the investor profile. But yeah, it's like an investment. Not only an investment, because we are creating some kind of closures that it allows you, if you nowadays I live in an apartment. If you go to live in a single home, you can, okay, I want my panels. I pay a little bit for the installation. I pick them and I put in your home. So it's not totally an investment. It's like an hybrid thing that we are working on.
Are your products only targeted for the Portuguese and European markets?
Actually, we are working mainly in Portugal. We are working in the countries that we have retail clients. In Portugal, in Spain, and in Brazil. But because it's really difficult because each country have its own kind of grid. If you go to the United States, the grid are completely different. The electrical installation is completely different. So even the meters and all these kind of things that it is needed to work are different. All the legislation are different. So it's kind of difficult to put like a mass product that works everywhere. It's not feasible. Yeah. Sorry.
How was the process to develop this product? Who had the idea? How did you communicate with the Whitesmith? How long did it take?
Yeah, so this kind of thing, it all begins with an idea. It's our team that do that. We are the product team, the marketing team. We analyze the trends, we analyze technology, we analyze that, as I said, technology are most of the times the begin of the things. We analyze the competence, not so much the competence, because we are dealing so much with things that I don't know, actually, it's not saying that we are doing a good job, but we don't know actually any utility that is far advanced as we are in these kind of things. So we analyze markets, we analyze clients, we talk with clients, we try to understand what they want, we try to see the future of the market, as I explained, and then it comes an idea. As an idea turns to flourish, we go to those innovation team and we discuss with them what do we have to do to make this happen. Sometimes it's difficult, sometimes it's more easy, it's easier, and we work closely with them to make this happen. So as the idea, okay, let's do it. Okay, we try to figure what we can do internally, what we need the help of partners like Whitesmith, and we work with them, and we try to develop the product. We test. That's one of the big. I missed one point. We always try to do like not only the product testing, like is it working? No, the commercial side. Are people willing to pay some money for this product? Are people wanting this product? I think it's one of the big problems mostly inside big companies. They are closed inside of its own companies, and okay, I think this will happen. I think this will work. I think these kind of things people want to buy. That's not true, because most of the times people don't want it. People don't. It's like a techie thing. Like our engineers want. Okay, I want this. We want to test in the market. We want to go there, and it's not a focus group. It's not like going to. Oh, okay, it's fine. Do you like this? I was talking with Rafael. Sorry, it's not a guy's thing, but there are examples, real examples. If there is a beautiful lady showing a product to a guy, the product will be better evaluated, and the guy will say, oh, "Okay, I want it." So that's not a market test. That's questioning a person if she or he wants to buy. What we always try to do is like testing the market, but the clients will not know that we are testing them. I'll give you an example. In the beginning, we are trying to figure out why the hell people buy solar. for reducing the bill, for producing their own energy, and I don't want to depend on those bad guys of EDP. For I am green and I want to protect the environment. For sure, if I ask most of the clients, okay, I'm green. I'm very green. I want to protect my sons and the future. It's very simple. What we have done is like making some AdWords, some pay. We pay like solar, EDP solar energy, reduce your bill. The next one, EDP solar energy, protect the environment. EDP solar energy, leave those guys from EDP. And by just monitoring the clicking rate, we know what people are caring about. And I can give you the answer. It's like reducing the bill. They don't care. And the last one is the environment. Because, yeah, and if you ask directly to people, they will say it, most of them will say it, okay, it's environment. So we have to, going to the answer to your question.
That's a right answer. It's just that the values are different, and the first value that it's money comes first, and that's why.
Yeah, but
because in the end, if you try to sell someone something that's on their average pay, and say it's green, I'm sure that people will buy it.
The green is a good thing. What we learn about the consumption behavior is that the word want is very, very strong. The word want, for all of us, if you want an iPhone, what is the rationale between buying an iPhone? It's that I want. Samsung, same things, Android, iOS, okay. But I want. I will pay lots. No, it's not the same. I know. I know. For you guys, they're not. Actually, it's not the same thing. It was a bad example in this kind of public. But what we have learned is the word "I want" is very important. I want a solar panel, but after that, they want to give a rationale for their decision. They already have made the decision. They want to reach home and tell their husband, okay, I'll buy this because of this, or to their wife, and I'll buy this because of this. They have to explain to themselves and to the others because why the hell they bought it. Okay, but the first word is I want.
And the iterations, how long did it take to develop this product, and how many times did you show this to the client when it was not yet finished? Like, did you show like semi-versions of the product?
Yeah, it depends a lot of the product. There are, like, if we sell solar, we cannot, it's difficult to show the product. You have to test it, to install it, and it's the time to market is like 3 months, 4 months, because it's not only solar. Because we have a self-consumption, we have to make like an online simulator to tell the client that they need one panel or 5 panels. There are lots of things, and all the operational sides, the boots on the ground, are really difficult, are challenging. But okay, 3-4 months you can put into the market. If we are talking about ready, it begins in 2011, I think. So
11?
Yeah, but
6 years since the idea to the market.
No, for the first it was 2 years for the first the launch.
Yes.
Yeah, for the launch, but it's always work in progress, always increasing functionality, the functionalities, the features. Yeah. So yeah, it could, but yeah, and that one we have to test a lot. Are the people understanding what is the feature? Are the people understanding how does the app is working? There are lots, and the much you do, the better. Okay.
What kind of investments have you made so far? Like it's big, it's a potential.
Yeah, I don't know exactly,
yeah.
But we have some kind of European funds also because it's integrating in smart networks. But I think like 2 million. I think. Yeah. Because also we developed some of course the infrastructure, but also we developed our own devices equipment. So it takes a little bit to go to the market, but we didn't find in the market anything like this. And because it's a new market, it's everyone, and as I said, it's completely different between here and between Sweden. And okay, we could find a Swedish company that has some kind of plug, but the plug doesn't fit our needs. So we have to develop in-house. That is okay. It might you may not understand, but for a big company like EDP to decide to develop its own equipment inside house, it's really a big thing. Yeah.
You mentioned that the grid is currently not able to buy dynamically from the consumer, right?
Yeah.
If I produce,
yeah.
It makes sense. For instance, in the peak of the summer, I have solar panels, and I cannot supply the everything of the neighborhood.
The big word is dynamic.
Is the technical problem of the grid? Is because of the consumer technical issue?
Yeah, you can.
It's illegal.
Yeah, it's everything. It's a legal one. It's for sure a legal one, but you have you can if you in a dumb model that you have like only a meter that's it will monitor what is the injected electricity into the grid, and you pay for that. Okay, that is completely possible. By the way, in the beginning of solar energy, there is a feed-in tariff. That the model is I will sell everything to the grid. I can put it into my vacation house in Algarve. It's okay. I don't need to consume. I just inject it into the grid. But it was a subsidized model. This kind of dynamics that is interesting in the future. That the grid needs now energy, and I want to buy now. That the grid technically. The grid is not feasible yet because the grid is like made to work in one side from the production, transmission, distribution, and then the consumption. It's not working. I don't know why. So I'm truly, but it's not working probably from the other way. And to manage because okay, I want to buy energy from clients, but which clients? Okay. The Mr. Antonio or Mr. Manuel, or from both, or from and the energy that I buy will from Mr. Manuel will be to Mr. Antonio. That takes a lot of a network from between PCs inside each home and internet, but in an electrical point of view.
And would you need different meters for that to happen? Or?
Yeah, we need. We have. All the European countries are developing smart meters. That are meters that allow you to connect from both sides, from the grid to home and home to grid. Yeah, but it will be needed also intelligence within the grid. Okay, and besides that, one big question in all this energy market is storage, because. As I said before, there are some moments in time that we have much more production that we need, and the question is that how we store it? How does we store it? Actually, in the pool price, if we go sometimes in the winter at night, the pool you can buy energy by like a stock, and it will cost you zero. But the problem is that what will I do with the energy? I cannot stock it. I can store it. So. The problem is, even if I buy, okay, it has to have the intelligence to store in the grid, or to put it in other clients to fulfill the consumption. So it will have to, and it takes a lot of investment. And the problem is that the grid. I don't know if you know, but the grid is not from EDP. The grid is like a concession. The grid is from the government that. We'll say, okay, EDP, nowadays it's EDP, you will manage the grid. So, who will make the investments to the grid? Are European, are Europe, are the government, are EDP that doesn't own the grid? So, that's that kind of questions that allows lots of money that are the problem.
Okay. And if you have a peer-to-peer deal, for instance, with one consumer, especially in the commercial side,
you are going to talk about blockchain?
No. I think it's possible.
Yeah.
But if if you have someone that is producing, you said about a factory that has a roof with the solar panels, and someone that needs a lot of electricity and wants to make a deal between them without involving NP, can that be using the grids? Can they make the deal and
Actually,
change?
I don't know. I don't know how to answer. I've heard some things about peer-to-peer, but I don't know what is needed from the grid to manage this, because the electricity flux is like dump. If you produce energy from your home, from solar panels, the energy will be to a home because it's closer. If the grid was closer than your home, the electricity will be to your home, because you don't have the capacity okay, I will produce this electron and go to that house. I don't know what is needed for now. It's like the closer the consumption, it will be. Even our clients that install already solar panels, they inject some part of the electricity to the grid. It's part of the system. In that simulation that I told you about, it says like, okay, you'll produce this. From this you'll self-consume this, and some part will you inject it to the grid. It's part of the system. It's impossible, or you have like some perfect consumption profile, or you inject it to the grid. And that energy, yeah, EDP will use it to put in your neighbor house, but it's an electron. It's a dumb electron that you don't know if it's from the north. Yeah, it's not from the north because it's far away. But the closer they are, the electron will go there.
A solution could be that many vizinhos could make a system together.
Yeah.
There are producers.
Yeah.
And there are consumers.
Yeah.
And they will optimize like EDP is doing with other consumers, because and then they will optimize what is produced and consumed.
Yeah, there are some kind of projects in this, like in the US and I think in Germany. There are some pilots of smart grids that work like community heating for solar production. It's like a mini grid instead of being like an entire country grid or an inside home grid or a neighbor grid, and it has to be managed. There's not a peer-to-peer, but inside your neighbor or your community, it's possible.
For example, we were talking about some time ago about a building that can't be done for the building for the common parts because the elevators have peaks, but for the whole neighborhood, for example, a building with 15 people. 15
it's possible for large condominiums and buildings that have lots of people and lighting and the irrigation pumps and everything.
No, I was talking about not the common parts, but the people. For example.
It's like a community, but it's not a vertical community. It's possible. It's possible. Not the legislation in Portugal doesn't allow that nowadays, but I think in the future it will allow.
Sorry, guys. Last question, please. Move on.
I need water.
There is a project in the desert of Sahara, which called Desert Tech, which will cost $400 billion, but it's not working because there are some wars in the Sahara. The project is the following: we have mirrors, and we control to optimize the mirrors to send back the energy of the sun to a single point. There are some tests in Spain and in America.
It's like the concentrate solar panels.
They concentrate. This is not photovoltaic panels, but mirrors concentrating the power to a single point, and then there is a common, usual thermic central that is producing energy. if I'm unable to find on internet a comparison between the rentability of such an investment and the same money invested in photovoltaic solar panels. Could you reply to this question? Because if I invest to such producing system or to the
I will try it.
other, what is the most interesting one?
No, the costs of the polycrystalline and monocrystalline solar panels are so low. One panel costs like 100 euros. Are so low that for now, no other technology in solar, I'm not talking about wind, no technology could in terms of rentability could challenge solar panels. Yeah, we have most of in 20 years from now we'll have like solar tiles. They already exist.
Yes.
Solar City, that is from Elon Musk, they are producing solar tiles, but they are quite expensive.
Sure.
So there are lots of technologies and things that even in the buildings, in the walls of the buildings, like put solar panels, but they are not. The rentability is very low. So in terms of investment, just a pure investment point of view, just solar panels are rental for now. It's like the on float wind in the sea. Okay, it's amazing. You don't have land. Okay, you put in the sea. There are lots of wind. There are space, but the problem is that the costs of producing that and transport the energy from the sea to the mainland are very high for now. But yeah, it's when you put in the terms of the investment perspective, not the I want part of things, you'll have always the most rentable product. Yeah, if I try to sell some CHP to one client, for sure there will be one or two clients that will buy. I want a concentrated solar power in my home. Yeah, but it's rentable. No.
And if you agree, there are solar panels which are double phase. Now, is it interesting? So you receive the light from one side, and they are able to make energy from the other side. Is it interesting or not? They are costing a little more.
I didn't know that, but what I know about solar panels, yeah, the solar panels, like depending on the latitude of your country,
sure,
depends the inclination of the panels. If you are in the Ecuador, the panels will have to be like flat. If you go to north, you have like this and like this. So, if you think in this way, what's the point of being? Because it will be always in the shade, the second side. I only see that in the North Pole. The panels will be like this. Yeah, it will be, but it will be in the North Pole. I don't see the point. I don't know the technology, but I don't see the point because the most rentable panels are going like more flat.
Okay.
Okay, I think you can talk with John in the end. So
Yeah.
let's move on to Pedro.
Okay. So thank you. Actually, I don't, but I can give you my email if you want.
So hello everyone, my name is Pedro. I work at Whitesmith. We've already talked a bit about it. We build products, product studio. And I'll talk a bit about my experience working on Cold. Cold is one of our internal products. We work a lot with IoT, and Cold is an IoT product. It was developed initially to solve a common problem in Portugal and in the world, which is we are by law we need to monitor the cold chains like freezers and all the freezers in restaurants and bars and places like that. And well, if they break, all the food will get ruined. And so not only we are trying to solve this issue by trying to monitoring them and making sure they don't break, but we're also trying to monitoring because we are ordered by law to do that. And so we built a solution in which we place sensors inside the freezers, and they communicate through the cloud to the system we built, and users can monitor these temperatures, and they will be notified if there's an issue with the infrastructure. So we build a lot of IoT products, and there are some common patterns and common architectures that we find in these projects, and so I wanted to talk a bit about what we found in Cove, and it's a bit common to all IoT projects. I will start with the common architecture for all systems. So we have devices that communicate to our system in the cloud through a communication module. This data will be stored in the database, and it will be analyzed by another module. There's also an actuation module that will turn off the device or make it do something. And those are usually triggered by either the client or the analysis of the data we receive. So the user communicates with the system through a user model that can, for example, retrieve data from the database or trigger an actuation on the system. So one of the characteristics of the system, of IoT systems in general, it's usually the performance issue. So like my colleague was telling you about, we have a lot of readings really fast, so even if you have 2 clients, they will be sending data, like messages at a high throughput, usually around seconds. So it's really easy to have few clients and get like 10,000 messages a second or stuff like that. Like it's really easy to load the system. And so one of the issues we try to mitigate is this, like how do we handle the load on these systems? Not only through high throughput message, but storing the data. So one of the patterns we use a lot, it's a publish-subscribe pattern. One of the platforms we use is Kafka. It's really interesting publish-subscriber that is able to handle high throughput. So it can reach millions of messages by second. So it works like this. It's really simple. So the messages communicate to a topic, and we have a service that receives those messages, processes them somehow, and publishes them to another topic, which is then served by our services. And so this has some advantages in terms of performance because the service is really fast, and also because we also get a lot of replayability. So if the service goes down, Kafka will still be storing our messages, and we can replay them easily, solving issues and keeping the raw data. Another issue is scalability. And when I mention scalability, I mean system scalability and like the flexibility of the system. So as we get more clients, the throughput will increase. We'll get a lot more messages. We'll have to store a lot more messages. We can also imagine we only get the temperature right now, but we can also get humidity next week, or the power the fridge is consuming, or other types of dimensions, or other type of readings. So like the system scales with the number of users, but it also scales with the features required by the system. And so these systems need to be fast in terms of development, and they also need to be, we need to be able to change the required performance of the system easily. There's also wide performance range. For example, we can have a system that stores messages every minute, and when the client connects to the service, they want to know if everything is all right. It can increase the throughput of the rate to seconds, so that the client can get a more accurate reading in this time frame. So the system needs to be able to increase the scale and decrease the scale as it's needed. And so one of the solutions we went here is using microservices. Microservice is a pattern that is quite common right now, I guess. Usually, on the old days, applications were a single application, a single block, a single system. And when we want to scale this system, we usually replicate it. So we got another machine with exactly the same system, and we will load balance the messages through all the nodes. But this is not very efficient because We can have, for example, the authentication service that makes sure the messages are valid. Maybe that one is really fast, but storing the data to the database is really slow. So we will be replicating both these modules unnecessarily. And through microservices, which divides our system into several parts, and they communicate through defined user interfaces, usually through HTTP or RFC. We can easily scale these systems and load balance just the part where we need to increase the performance. And it also has another advantage, which is we can use the best tool to each job. So, for example, we can, if we're working with artificial intelligence for analyzing our data, maybe it's interesting to do it in Python because there are more libraries, it's better. And for storing the database, maybe you want to work with C or something. It's really easy to divide our system into work with individual parts. But the issue with this, besides a bit more latency in the messages, it's the operational part. As we scale, like coming back a bit, scaling the monolith in terms of operations, it's really easy. We just add a load balancer and we replicate the node. We don't have to handle anything else. When we're working with microservices, they will be sparse between the nodes. Maybe some of them will be in one node, some of them will have to communicate through nodes in the network. And we have to manage how many there are if we are scaling individually each node, each service. How many of them are available? If one crashes, what happens? So there's a higher operational cost to all of this. In one of the solutions we work is with Docker. Docker, it's well, it's a new kind of virtual machine that's a lot lighter. So what happens? It uses part of the operating system on the host. So, for example, if you're working with virtual machines, besides on top of the infrastructure, we have the operating system, and then we have, for example, other virtual machines which are running their own operating system that is virtualized, and the application on top. So the guest operating system on the virtual machine, it's not doing anything. It's just there because it's needed. Like it's just wasted resources. And with Docker, the way it uses part of the host operating system, it only has the part it really needs to run the application, independent of the operating system. So it's a lot lighter. Although it doesn't use virtualization, it just uses some Linux system parts to isolate the processes, while retaining a lot of the advantages of virtual machines. And we also use Kubernetes. So, like I was saying, when we have a lot of microservices, the nodes start to get a bit of a mess because I don't know which machine is running what. If one of them crashes, I need to start it somewhere else. I need to make sure everything is working. If one of them stops working, I need to know how and why. Like, there's a lot of operational complexity to all of this, and also not only in managing them, but also where do I put them? So if I try to do this manually, it will not be efficient. I will not be able to choose the best place on my cluster to put my service, because there's a lot of there could be a lot of nodes, there could be a lot of different resources that are needed. And so Google developed Kubernetes. It's a system that schedules the containers, so, and the nodes. What happens is I have a Kubernetes service that connects to all of the nodes on my cluster, and I simply give Kubernetes my container. I say, I want this service to run on my cluster. I want to have 3 of them, and they will use around like 200 megabytes of RAM. Where do I put them? And the Kubernetes system will automatically put them in the right place, like in where it thinks it's the best place to put my service, based on the available resources and the other algorithms that can be used. It it also has a few other advantages in terms of making sure everything is running. So if one of my services crashes, it will find out and it will restart it. It also handles secrets, so I don't need to put my secrets, for example, API keys. I don't need to put them on the configuration files. I don't need to put them on the containers. I can supply them to Kubernetes, and it will make sure the containers get the secrets and configuration files and stuff like that. And we'll also, for example, if this node dies, Kubernetes will see that it died, and it will reschedule those containers in the other parts of my system. So not only will it handle service failure, it will also handle node failure. And the system will get a lot more stable.
Sorry, do you need the Dockers to work with Kubernetes?
I think it also handles other types of containers, but it's mainly aimed at Docker.
You need containerization. It's
Yeah.
like a smart load balancer for containers.
Yeah, it also does that in the load balancing. For example, if I have these blue services and one of the red service wants to communicate with the blue service, it will simply, for example, for an HTTP request, it will simply ask a name that I choose, and that message will be load balanced to one of the blue services. It will handle all of that. So coming back a bit to the architecture part, I think monolith is still very interesting for when you're trying to prototype a system, because it's really fast to get it working, and it's like handling stuff like network issues and replication at service level. It will take some time. It will definitely be slower at the start. But over time, what we find is that if I want to, for example, if I have this service, this application, for example, it sends data to a system, make sure the messages are valid, it will store them to the database, analyze it. So it's like a pipe and filter. It will do operations. But if now I want to also check if the temperature is correct, like around the middle, like I want to add another module to my application, this will require me to change the code on this module to now send it to that one. That one needs to know that instead of this one sending the information to go to that one, I need to take down my system to update it with the new changes. And with microservices, this really doesn't happen, because I can just add this new service, and I won't have to redeploy the whole application and just create that service. And so coming back to the architecture, I spoke about in the beginning. So I would put PubSub, Kafka. It's a good example, but there are also others. And I would use services for the rest of the modules. So zooming in a bit on the analysis services, I can have, for example, a service that runs every hour, checks the database, processes some data, and does something with it. For example, it stores the reports to the database. So I get a bit of a batch processing. It runs sometimes. I can have another service that runs when I get messages pushed to Kafka, for example, from the devices. Messages will go to Kafka, it will be analyzed by this service, and it will, for example, send a notification to the user. Maybe the temperature is too high. It will send the notification to the user. If I want to deploy a new service that also gets the same data that this service gets, to maybe use, try to find out if the temperature is too high, and then it will send a message to my device. I'll simply deploy that service, and I will tell it to consume the same topic from Kafka, and it will talk to the activation services. So I didn't need to redeploy my application. I didn't need to change this code. Like I just tell it where to get information. It will just work. So prototyping, using monoliths to prototype, it's very fast in the beginning, and I can get a working module easily. But over time, this pattern gets a lot faster. It's a lot easier to develop. It's a lot easier to maintain, and it allows people to work with different technologies in each of the services. Well, that was my. Thank you. Any questions?
Yes, just a small question. Which time series database do you prefer?
I currently use Cassandra as a data store, and I use KairosDB, which is a bit of a front end, a stateless front end to Cassandra that handles all the working with time series itself, but doesn't actually store the data. So it's really easy to replicate. Yeah, the data is stored in Cassandra.
Sorry, what's the name first for the
Kairos,
Cassandra and then the
KairosDB.
And how many sensors are you talking about?
Actually, I'm not sure.
The billion?
No. Currently, a few hundred. Yeah, thousands, maybe hundreds. Yeah, currently the system is relatively small, but what I found it's really easy to scale. So, the way the system is now, it will be able to handle, from my estimations, like around 9 million devices. Like I won't need to change anything because the performance is so high on the Kafka, and we're also using Go to build the services. So the system is really performant, and I won't have to change anything. Yeah.
In that architecture,
yeah.
What kind of things are running in containers, and what kind of things are not running in containers? I'm guessing the database is not running in the container.
Yeah, actually is like the whole system is running in containers. And the reason for that, like if I would go with the SQL database, I probably wouldn't use containers.
Right.
But the way Cassandra works, because the data is replicated through all the nodes, and it's really easy to turn up a new node and turn down a node. Like if half of my cluster dies, it's not an issue. The data is still there. And
it rebuilds itself.
Yeah, exactly.
And for instance, for interfacing with the Python, you said you were doing back analysis with Python. Do you interface directly with Cassandra, or are you using some kind of?
The way KairosDB works, it has a HTTP front end. So I work with it through the HTTP part. Like if it also has a telnet and other stuff if more performance is needed, but because I work with the data usually works in batches, because if I want the raw data, I go through the Kafka itself and I get the real-time data. The performance is good enough, yeah.
You mentioned that Kafka can replace when something is getting broke. Can you ensure the way the data is reaching the services? Can enforce the FIFO is still there, for example?
Yeah. So the way Kafka works, it's really easy. Like it's really simple. The way it does it, it has a log, and messages are written to the log.
Okay.
And the client just say, I want message 25, and it goes to 25, and it starts there. If I say I want the messages from 10, it will start from 10. Like it will hold my data for a whole week, and I just tell it to where I want my data from. Because I want my services to be stateless, I don't want them to have to know which message they've already used. Kafka uses uses Zookeeper for a consensus and to store that data. So that data, it's like I know which messages are committed. So yeah, it's a persistent
queue. Can you know which message? What was your last message? For example, if when service shuts down, he persists the message and goes there. And, my last one was the 20. I went from there.
No, it doesn't need to. I just tell him I'm service A, and it knows that service A it's on message 24. So if I want to replay those messages, I can tell it to give me from message 10. But I can also tell it I'm service A, and it knows that service A as it's on message 50.
And you have for example a queue, and you consuming the queue like RabbitMQ or something.
Yeah, it's like RabbitMQ. Yeah, it's just like it doesn't have as many features. Like it's not so feature heavy. And the protocol, because it doesn't use MQTT or MQB, it's a bit heavier. Like I'll waste more internet, I guess. But the performance is like 100 times better, like really, really high.
How many developers were working on this project?
Mostly myself on this project, yeah.
So which kind of predictive problems are you trying to solve? Like we're trying to predict when some part of the refrigerator will fail, or are you trying to predict how much more input you need at a given time of the day?
So that part of the project it's a bit similar to what we're talking about EDP. So we're still working on it, not actually in production yet, but we're also trying to monitor the consumption of the freezers and try to find failures through that consumption.
Okay. And these models, are they trained in real time? As soon as you get like another data point, another point in time, you get more data, and you feed it to the model, you update the model like in real time?
Yeah, we actually use another service, another product from our company, which is called Unplug, and that's the product that actually handles that part of the system. I didn't work on that part in that project, so I'm not sure how it actually works.
This is basically a data-driven module, just to get the data.
Yeah.
And then you have another model that analyzes the data and gives the alerts.
Yeah.
But I'll just like reformulate my question, so maybe you can answer. Do you train a model from scratch every now and then?
I actually
and
don't
you
know.
replug it again into the module?
It depends on the model. So we have the context of code, which is a product for cold chain monitoring. Here at this point, we don't have any particular models running on production. We have some ideas, some prototypes, but there's nothing that's running in production, getting data in real time and being feedback. The other service that Pedro was talking about is Unplug, which is basically machine learning as a service. We have one model that you can find online is forecast. So if you send a set of data, a time series data, we can forecast that time series for the future. That's not fine-tuned as you go. There's a different set of analysis. But we also have other models that we have R&D basically that are not publicly available at least. Obviously, we are also trying to understand if there is a fit in our cloud for this or that model that use that. It really depends on the case. In some cases, it's useful.
Yeah? Okay. Thank you, everyone.
Thank you. Thank you.
Esse é o ponto. Quando nós para controlar equipamentos, ou a máquina de lavar. Agora diga-me a máquina de lavar, estou a fazer excesso, vou utilizar as lavar. Este tipo de automatização de inteligência cada vez mais se expõe. Eu não quero saber, eu não vai programar a máquina que eu costumo produzir e resolver. Se calhar nós fazíamos, analisar mais meses e aqui